Hello guys, welcome back to my channel. I'm Abhishek Podil. Today I'm going to solve a problem from Fundamental Concept of Fluid, which is the chapter of fluid mechanics. You can see here a system of parallel plate moving above a fixed bed, and you can see different liquid having viscosity mu and 2 mu. And according to the question, both the plate have the same area here, same area A, and the pressure is same everywhere, constant everywhere, and the fluid is obeying the Newton's law of viscosity. So that's why this is also an application of Newton's law of viscosity. We are going to apply the Newton's law of viscosity principle here to solve this kind of problem. In this problem, you are supposed to find out the velocity v of the middle plate in terms of capital U in question number A, and also the question is asking you to find out the force F required to move this plate in this direction. The arrow is showing the direction. Force F required to move the plate in this direction with velocity capital U. It is asking in the question number B. Okay. So let's solve this problem step by step. To solve this kind of problem, you are supposed to understand the system of force acting on the plate due to the motion of this plate and due to the viscosity of the liquid as well. When this plate, this upper plate, this is the upper plate, and this is the middle plate, and this is the boundary, which is a fixed boundary here. You can see, and all the thickness are given here, 2h, and the viscosity of the liquid in between are given here mu and here 2 mu. Let's assign the system of force here due to the motion of the plate. Okay, so this upper plate is moving in the rightward direction, so that's why the shear force acts in the opposite direction of the motion, Fs. I say this Fs, and there is no shear force acting above the plate because there is no liquid in this case. So that's why only the shear force acts in the lower portion of the upper plate. And when this upper plate moves in this direction, the liquid attaching with this also moves along the direction. Okay, with different velocity. Here, in this point, the velocity, the liquid attaching to the plate moves with velocity u, and it will go down. As it goes further, distance. So that's why here the velocity u and the velocity v here. Due to the motion of the plate, this middle plate also moves with the velocity v, but you have to understand that the velocity u is always greater than v. In this case, because it is not attaching, this is the medium is a liquid, so that's why the velocity u is always greater than v here. So, due to the motion of the upper plate, this middle plate also moves with velocity v, and this liquid in between all moves with velocity, different velocity. Here you can see here u. Attaching to the portion moves with velocity u, and here it moves with velocity v. So due to the motion of the liquid in the rightward direction, so it will exert a drag force, which is also called a shear force, F shear in the F shear up, in this along the direction of the motion of the upper plate. So that's why the direction is in this direction, rightward direction here. So this is unlikely different from others. Due to the motion of the upper plate, it exerts a force toward the direction of the motion. Above the middle plate. Okay, you have to understand this one. And let's go into the middle plate. And when the middle plate moves due to the motion of the upper plate, it moves, and due to the motion of the middle plate, it exerts a force opposite to the direction of the motion of the middle plate. Okay, so it is moving in this direction, and it exerts the shear force F shear down, below the middle plate. So this is the system of force. You have to understand this system of force. This is different than others. So that's why. And let's apply the Newton's law of viscosity here. And let's apply the Newton's second law here to solve this problem. Okay. So now I'm going to take you to the middle plate. Let's stay on the middle plate first. Okay. So let's stay on the middle plate. So in the middle plate, let's apply the Newton's law of viscosity. Okay. So in the middle plate, let's find out the F shear up here. So F shear up is tau shear up into area. The area is same. The area is same for the middle plate and the upper plate. Okay, so it is given in the question. And how to find out the tau shear up? Tau shear up is mu du by dy, which is the Newton's law of viscosity. Okay, mu du by dy into area. You can just do like that. And let's mu is how much in this portion. Let's stay on the middle plate and the boundary. For the middle plate, the boundary is upper plate. Okay, so in between the middle plate and the upper plate, there is a liquid having viscosity, mu and thickness 2h. Okay, so that's why here thickness is denoted by dy, and which is equal to 2h here. In the portion between middle plate and upper plate, there is a thickness 2h. dy is 2h. Okay, and the viscosity is mu here. Viscosity is mu in between the middle plate and the upper plate. and the du, and the du is how much? Du is the changing velocity between the extremity of the liquid layer. Okay, so what is du? Du is the changing velocity. Changing velocity, that is u minus v, because u is greater than, I am going to write it u here, u minus v. So du is the changing velocity between the extremity of the liquid layer. Okay, so let's substitute over here. We are going to get f shear of is equal to mu. Du is how much? U minus v divided by dy is how much? Dy is 2h into area. Okay, you can say this as equation number 1. Okay, so you have got the f shear of by staying on this portion. Okay, between the middle plate and the boundary of the middle plate, that is upper plate. Okay, we have got the f shear of by applying the Newton's law of viscosity. Okay, so now let's stay on the lower portion. This is the middle plate, upper portion, middle plate, upper portion, and let's stay on the lower portion of the middle plate. Okay. Okay, let's stay on the lower portion of the middle plate here, in between the middle plate and the fixed boundary. Okay, there is a viscosity 2 mu and there is a thickness small h. Okay, let's stay on the lower portion here, lower portion of the middle plate. Middle plate, the lower portion of the middle plate. F shear, we are going to find out the F shear down. Okay, F shear down. To find out F shear down, tau shear down into area is same. Area is same. At the upper portion and lower portion. That is tau shear down is equal to mu du by dy into area. Then how much is du here? How much is mu here? How much is mu? Mu is 2 mu here. So that's why mu is 2 mu. And how much is du here? How much is du here? Du is the changing velocity. Du is the changing velocity, which is changing velocity to the extremity of the liquid layer. We are staying on the lower portion, so the changing velocity of the extremity, that is v minus 0. So that is du is v minus 0. That is v. And dy is how much? Dy is the thickness. Dy is the thickness of the oil layer, that is small h. Dy is small h. So let's substitute over here. You are going to get F shear down. F shear down is equal to 2 mu. Du is how much? V a divided by h. 2 mu va divided by h, which is 2 mu va divided by h, which is the F shear down. We have got the F shear down by staying in this lower portion. We have got the F shear up by staying on the upper portion with respect to the middle plate. Okay, so now we have got these two forces here, and let's apply the new. Let's stay on the middle plate. Let's suppose the middle plate is a control volume. So let's stay on the middle plate and let's apply the Newton's second law here. Okay, so we are going to apply the Newton's second law, and you have to understand that this v velocity are constant velocity. Constant velocity. When the velocity is constant, the acceleration is going to be 0. You have to understand this. Okay, so let's apply the Newton's second law. Now apply the Newton's second law. We have applied the Newton's law of viscosity and got the force here. So now let's apply the Newton's second law by assuming the middle plate is a control volume. So let's stay on the middle plate. We are still in the middle plate, and we are applying the Newton's second law. That is Newton's second law is summation force is equal to mass into acceleration. Acceleration is 0 because there is no change in velocity. The velocity is constant here. The velocity is constant in the middle plate. So the velocity v is constant. So there is no, the velocity constant. So that's why v constant. That's why you can say the acceleration is 0 here. Okay. So when the acceleration is 0, the force in the rightward direction you are going to say positive. Here you can say F shear up minus F shear down is equal to 0, because we have just the control volume is the middle plate. So that's why we can do this. Okay, the weight of the plate is in another vertical direction, so we are now not going to suppose the weight. Okay, because there is no weight is still not given, and we are applying the force in this horizontal direction. So that's why that we are not supposed to put the weight. Okay, so F shear up, how much you have got the F shear up? You have got the F shear up, that is mu u minus v divided by into a divided by h is equal to minus, it goes in this rightward direction, is equal to F shear down. How much is the F shear down? F shear down is equal to 2 mu VA divided by, here 2H and here small h. Okay, if you substitute this f shear up and f shear down, what would you get? You know, the area is cancelled out. You know, the viscosity is cancelled out. You know, h is cancelled out, and you are going to get, you know, you are going to get the u is equal to 5p. Okay, the condition you are going to get u is equal to 5p. If you solve this out and so, you know, we have assumed the control volume. This middle plate is a control volume, and we have got we apply the Newton's second law, and we get this condition. Here the u is 5 times the velocity of the middle plate. Okay. The question is asking in this one, and in the question number A, what will be the velocity v of the middle plate in terms of u? So that's why you can do that. Do this one. V is equal to u by 5. Okay, you can see this. Okay, this is the relationship which is asking in the question number A. Now I hope you get up to this point. You know, if you have any confusion, you can write the comment in the comment box. Okay. So now let's get into the another question, that is what is the force F required to keep the upper plate at velocity u? So the force required F, you know, the force required F is how much? The force required F is, you know, is equal to this Fs. You know, you can now let's stay on the upper plate. Let's apply the Newton's second law on the upper plate. Let's stay on the upper plate. You know, that is in the upper plate. You can say that net force is equal to mass into acceleration. The acceleration is 0 because the velocity u is constant. So you can say here net force, that is F minus Fs is equal to 0. That is F is equal to Fs. Okay. So now the force F is equal to Fs. In this case, if you assume the upper plate is a control volume. Okay. You have got this, and now let's get the shear force Fs by using the tau shear off. Okay. By using the tau shear off, we are going to get the force Fs. So let's get the tau shear off. Okay, tau shear off is how much? Tau shear off is equal to mu du by dy. Okay, in the upper portion, how much is mu? In the upper portion, mu is mu. We have already done this. We have already got this. That is mu is mu. Du is how much at the upper portion? At the upper portion, du is u minus v. U minus v. Okay, we have already done this one. So I am repeating this. So u minus v, and dy is how much in the upper portion? Dy is, you know, dy is 2h in the upper portion. So dy is 2h in the upper portion. So if you substitute here, you are going to get the tau shear off. Tau shear off, that is mu u minus v divided by 2h. This is the tau shear off. Okay. So if you get the tau shear off, if you multiply this tau shear off by area, because the area of both plates are same, so you are going to get the Fs. Okay. So Fs is equal to F finally. You know, by applying the Newton's second law. Okay, we have got the tau shear off. Now let's go get the Fs. Now let's get the Fs. Okay, so we are staying on the upper portion. Understand? Fs is equal to tau shear off. We have already calculated this, and just write down here tau shear off into area. Area for same for the both plate. Area A, same for the both middle and the upper plate. So that's why, you know, if you substitute over here, you are going to get you know, mu u minus v into a divided by, you know, into a divided by 2h. You are going to get this, you know, and now substitute the value of, that is substitute the value of you know, u here. We have got u is equal to 5b. Let's substitute u is equal to 5b over here to get the final expression of the force. So now let's substitute u is equal to 5b over here. So now let's substitute Fs is equal to mu into u is equal to 5b minus b into a divided by 2h. You are going to get Fs is equal to mu 4v into a divided by 2h, and finally you are going to get the force Fs is, you know, the force Fs is finally Fs is equal to 2 mu va divided by h. This is our expression, which is required expression, 2 mu va by h, which is the Fs is the shear force acting opposite to the direction of the motion, and finally by applying the Newton's second law, you can say Fs is equal to f. So that's why f is how much? The f is equal to Fs is equal to 2 mu VA divided by H. Okay, this is how you solve the problem, and this is how you apply the Newton's law of viscosity and Newton's second law to solve this kind of problem. And keep in touch with my video, and I'm going to solve another kind of problem, different type of problem where there is an interface, there is no plate, and what would happen in that case if there is no plate in the middle and the liquid are separate different liquid are placed, and what will happen, and I'm going to tell you in another video. So keep in touch with me. Okay, best of luck for the upcoming exam. Okay, thank you so much for watching this video up to this point. Okay, if you have any confusion, write the questions, queries in the comment box. Thank you.